Welcome to the debate. You know, when we look out at the ocean at night, the darkness feels, well, alive.
Right, yeah. Even if you can't see the marine life, you know it's there.
Exactly. You can sense that hum of biology beneath the surface. The water is just teeming with it.
Because it's an ecosystem. I mean, even in the pitch black, your baseline assumption is presence, not absence. You don't need to actually see the bioluminescence to know the deep is occupied.
But when we point our most advanced radio telescopes at the night sky, peering into this ocean of billions of stars and potentially habitable planets, we don't hear a hum. We hear absolute, deafening silence.
It's unsettling.
It really is. We are staring into a void that, statistically speaking, should be crowded, yet we detect absolutely no sign of sentient life.
Which brings us to the core of our discussion. We are framing this around Robin Hanson's great filter theory.
Right, to explain this massive tension. And the core disagreement between us today is temporal. Is the great filter in our deep evolutionary past, meaning we are a profound mathematical anomaly?
Or does it lie in our future, as a technological trap just waiting to destroy us or force us into hiding?
I firmly hold that the great filter is behind us. I mean, the sheer mathematical improbability of complex life forming means we are likely entirely alone, making the universe's silence a natural abiotic emptiness.
And I take the opposing view. The observable universe is simply too vast, and the numbers are far too overwhelming for early biological hurdles to explain a completely empty cosmos. I argue the filter is still ahead of us. Life is likely common, but civilizations either inevitably self-destruct through technological traps, or they deliberately, terrifyingly hide to survive.
To understand why I place the filter in our past, we have to approach this from a position of cold, analytical probability.
The rare Earth hypothesis, right?
Exactly. We lean heavily on Peter Ward and Donald Brownlee's rare Earth hypothesis. When we think about life, we naturally, and I think dangerously, assume that once you have liquid water, intelligence is an inevitable march forward.
Which ignores a lot of history.
So much history. The evolutionary and geological history of Earth tells a story of a staggeringly improbable sequence of events. We aren't just talking about abiogenesis, that initial spark from non-living chemistry to self-replicating molecules.
Right, getting self-replicating molecules is just the first hurdle.
Exactly. We are talking about the leap to eukaryotic cells, the transition to multicellularity, and the specific planetary conditions required to sustain an unbroken chain of development over 4 billion years.
I understand the appeal of the rare Earth hypothesis. I really do. But we are looking at an observable universe that contains an estimated 10 to the 22nd power habitable planets.
It's a massive number.
It is a 1 followed by 22 zeros. With that immense volume of galactic real estate, arguing that early biological hurdles can explain a completely empty cosmos, well, it strains credulity.
Even with the odds stacked against biology?
Yes, because even if the odds of complex life forming are 1 in a trillion, there should still be billions of civilizations out there.
I see why you think that, but let me give you a different perspective on the sheer difficulty of those early biological steps.
Okay, let's hear it.
You dismiss the biological bottleneck by relying on the vast number of planets. But let's look at the actual mechanism of Hanson's hard steps in evolutionary history. On Earth, life emerged relatively quickly after the planet cooled, which tricks us into thinking biology is easy.
Right, the simple prokaryotes.
Yes, but then life hit a massive wall. It remained as single-celled, simple prokaryotes for billions of years. Billions. Why? Because simple cells just do not have the internal surface area to generate enough cellular energy, enough ATP, to build complex multicellular structures. They were thermodynamically trapped.
Well, they were trapped until the event of endosymbiosis.
Which happened exactly once in 4 billion years of Earth's history.
That we know of.
But look at the mechanics of it. The leap to eukaryotic cells required an archaean to swallow a bacterium, fail to digest it, and instead of dying, perfectly integrate the bacterium's genetic replication to form a symbiotic power plant the mitochondria.
Right.
It's like tossing two completely different combustion engines into a blender and having them miraculously fuse into a perfectly functioning, hyper-efficient warp drive.
That's a fun analogy.
But it highlights the absurdity. If complex life were a natural, inevitable progression, we should have seen endosymbiosis happen multiple times, independently across different domains of life.
Sure.
The fact that it took the Earth 3 billion years just to figure out complex cells proves how staggeringly difficult the leap to complexity is. And that's before we even factor in the geological lottery.
I come at it from a completely different way. The argument you are making is a textbook example of ascertainment bias.
You mean the anthropic principle?
Closely tied to it, yes. Yes, endosymbiosis is incredibly complex. And yes, the development of mitochondria seems like a freak occurrence.
A literal biological miracle.
But we are looking at our own evolutionary history and concluding that because certain steps took a long time here, or happened only once here, they must be universally improbable everywhere.
They are objectively improbable steps, though.
But we are only here to observe the silence and to have this debate because we happen to be the species that survived those steps. Our perception of how rare life actually is completely skewed.
But observing our survival doesn't invalidate the mathematical improbability of the hurdles we cleared. Earth isn't just a rocky planet in the habitable zone.
It's a highly engineered sanctuary in a way.
Exactly. We have a disproportionately giant moon that stabilizes our axial tilt. Without it, our climate would swing chaotically, making the long-term evolution of complex ecosystems impossible.
Making long-term evolution impossible.
Right. We have Jupiter acting as a gravitational vacuum cleaner, deflecting planet-sterilizing asteroids. We have plate tectonics functioning as a global thermostat by cycling carbon. You multiply the probabilities of all these necessary independent variables, and the likelihood of clearing them all approaches zero.
It approaches zero, but it isn't zero. And when you multiply an extraordinarily tiny probability by 10 to the 22nd power, you still get a very large absolute number of civilizations.
You're relying on the lottery ticket analogy.
Because it works. We are the lottery winners marveling at the fact that someone won and then concluding that winning is so mathematically absurd that no one else in the entire world could possibly be holding a winning ticket. To argue that we are entirely alone, human civilization would have to be uniquely exceptional to an extreme degree.
I just think human civilization is uniquely exceptional.
To that degree. The probability of life arising would have to be less than 1 in 10 to the 22nd power. Betting on human uniqueness to that degree is a dangerous assumption.
How so?
Because it leads us to a much darker conclusion. If the math dictates that other life should exist, the fact that we don't see them means the great filter is a late-stage barrier.
Then we must confront the mechanics of your late filter.
Let's do it.
If the math dictates that millions of civilizations should have naturally cleared the biological hurdles, why is the cosmic ocean completely empty? What exactly is this universal executioner that operates with such flawless, galaxy-wide precision?
I'm sorry, but I just don't buy that it requires a flawless executioner. Let me tell you why. The late filter is likely a technological trap that no one survives simply because of the laws of physics and the nature of technological acceleration. So progress itself is the trap. Exactly. The power of a civilization's technology always scales exponentially faster than the wisdom of the civilization wielding it. Take the Jevons filter, for example. Runaway climate and energy overshoot. Right. The mechanism here is critical. In the 19th century, William Stanley Jevons observed that making steam engines run on less coal didn't reduce coal consumption. It made them cheaper to operate. It made them so cheap and useful that factories put them everywhere, which skyrocketed total coal use.
The paradox of efficiency driving higher total consumption.
Yes, and apply that paradox to a planetary scale. As a civilization advances toward becoming a Kardashev Type 1 civilization, meaning it harnesses all the energy of its home planet, every leap in energy efficiency exponentially accelerates its total planetary energy demand, propelling them toward ecological overshoot. Exactly. Boiling their biospheres before long-term sustainability can ever be achieved. And if environmental collapse doesn't get them, the philosopher Nick Bostrom's existential risks will.
You're referring to his urn of invention metaphor?
It perfectly illustrates the mechanical trap of progress. Imagine technological advancement as reaching into an urn and pulling out balls. White balls are beneficial, like penicillin.
Sure.
Gray balls are mixed blessings, like fossil fuels. Bostrom posits that there is a black ball in the urn, a technology that by its very discovery guarantees the destruction of the civilization that invents it.
Like unaligned artificial general intelligence.
Or weaponized self-replicating nanotechnology. The mechanism is the same. Humanity is walking a tightrope right now, pulling from that urn. The silence of the stars suggests that every single civilization eventually draws a black ball.
That's an interesting point, though. I would frame it differently. I don't deny that existential risks are real and present dangers to our civilization, or any civilization.
But
My objection lies in the absolute, uncompromising universality required for the late filter to actually explain the Fermi Paradox. Think about the statistics of biological and sociological variation. If 1,000,000 civilizations arise across the Milky Way, is it mathematically credible that every single one of them draws a black ball and dies?
100% of them? Given enough time, yes. A black ball isn't something you can uninvent. Once it's drawn, it's drawn.
But biology thrives on variation. Surely, out of 1,000,000 technological species, one would be cautious enough, or lucky enough, or culturally authoritarian enough to survive their technological adolescence.
You think they'd successfully regulate the danger?
They might heavily regulate artificial intelligence or ban nanotech. And if even one civilization out of millions survives and begins colonizing the galaxy, transitioning to a Kardashev-type 2 civilization, building Dyson spheres around their host stars, they would emit massive, unmistakable technosignatures.
Assuming they want to be seen.
The great filter must be a nearly perfect barrier. A 99.9% lethal future filter still leaves thousands of galactic empires lighting up the cosmos. Requiring a 100% extinction rate makes a late filter highly improbable as the sole explanation for the silence.
That is a compelling argument, but have you considered the possibility that they didn't all die?
What's the alternative?
You are assuming that surviving a technological adolescence naturally leads to loud, visible, expanding galactic empires. You assume that if they survive, they broadcast. But what if the survivors are out there and they are simply terrified?
Cosmic sociology.
This brings us to Lou Cixing's dark forest theory. It provides a mechanism for the silence that doesn't rely on a 100% extinction rate. It makes the cosmic silence feel heavy, structural, and entirely intentional.
But why would every surviving civilization independently choose to hide?
Because of the ruthless game theory of cosmic sociology. The dark forest theory relies on two primary axioms. First, survival is the absolute paramount need of any civilization.
Makes sense.
Second, the universe contains finite resources, while civilizations naturally seek to expand. When you combine this with the sheer vastness of space and the hard limit of the speed of light, you get what Lou calls the chain of suspicion.
The impossibility of verifying intentions across interstellar distances.
Exactly. Think about the prisoner's dilemma on a galactic scale. If you detect another civilization, what do you actually know about them?
Nothing.
Practically nothing, yeah.
You don't know if they are peaceful explorers or a predatory swarm. And worse, because of the possibility of a technological explosion, where a seemingly primitive civilization could experience rapid advancement and suddenly become a threat in a mere 1,000 years, you can never trust them.
So you strike first. You cannot afford to wait for a communication round trip that takes centuries to verify their benevolence. The math of survival leaves you with exactly one rational game-theoretic move. You pull the trigger first to eliminate the potential threat.
Preemptive strike?
In this scenario, the universe is a dark forest. Every civilization is an armed hunter stalking through the trees. The silence we hear isn't dead space. It is a universe of hunters hiding in the brush, knowing that anyone who strikes a match and reveals their position will be instantly destroyed by a relativistic kill vehicle.
I'm not convinced by that line of reasoning.
Why not? The logic is sound.
Game theoretically, maybe, but it fundamentally misunderstands the physics of observation and the transparent nature of space. The dark forest theory is a brilliant piece of science fiction, but it falls apart under the scrutiny of thermodynamics, specifically the detection paradox and the adaptive equilibrium theory.
How so? I mean, space is unimaginably vast. Hiding in a forest of hundreds of billions of stars seems entirely plausible.
Hiding a submarine in the ocean is plausible because water is dense, it absorbs light, and it masks thermal signatures. Hiding a highly advanced, energy-hungry civilization in the cosmos is fundamentally thermodynamically impossible.
Because of waste heat?
Exactly. The dark forest theory relies entirely on the hiddenness assumption that civilizations can remain undetected as long as they don't actively broadcast radio signals.
Which they wouldn't do if they're hiding.
But any civilization advanced enough to pose a galactic threat must consume massive amounts of energy. According to the second law of thermodynamics, using energy produces entropy in the form of waste heat.
But surely a civilization millions of years ahead of us could engineer highly efficient systems to capture that heat?
Efficiency actually makes the problem worse. Even if you capture heat to do more work, eventually that energy must be radiated away, or the civilization will literally melt its own infrastructure.
So they glow in the infrared?
It's like trying to secretly operate a hyperscale supercomputer data center inside a completely transparent glasshouse in the middle of the Mojave Desert at high noon.
Okay, that's a vivid image.
If you can paint the servers black, you can turn off the monitor screens, you can put the whole thing on silent mode. But the sheer volume of infrared waste heat you generate will make you glow like a beacon to any thermal sensor in orbit. An advanced civilization cannot mask its thermodynamic waste or the massive physical alterations to its host star's radiosphere.
I see your point.
If the galaxy were populated by hiding hunters, our infrared telescopes would detect the glaring anomalies of their energy consumption. The dark forest fails because you cannot hide indefinitely.
I think you are underestimating the technological capabilities of a Kardashev Type 3 civilization.
In what way?
If they are hyper-aware of the dark forest dynamics, they would engineer their society to minimize thermodynamic waste or direct it into dimensions or mediums we cannot yet perceive.
Now we're getting into magic physics.
No, we are looking for waste heat using 21st century human physics. A civilization operating at a galactic scale might utilize physics we haven't even theorized yet.
That's a huge leap, though.
Furthermore, astrophysics models examining game theory note that the dark forest represents a stable Nash equilibrium. The risk of annihilation is so absolute that any species that fails to perfectly hide is wiped out.
Leaving only the perfect hiders?
Right. The ones that remain are the ones that have perfected concealment. If we assume they can't hide, we are assuming our current understanding of thermodynamics is the absolute pinnacle of universal knowledge.
It's not about human arrogance. It's about the fundamental constraints of the physical universe. Even if we grant them magical heat-sinking technology, what about their expansion?
They might choose not to expand.
A civilization restricted from expanding to gather more resources would eventually stagnate and collapse, the crunch scenario Bostrom warned about.
True.
If they do expand to survive, they inevitably alter their environment on a macro scale. We have surveyed over 1,000 nearby stars with unprecedented sensitivity through the Breakthrough Listen project. We are looking for Dyson swarms, artificial atmospheric pollutants, large-scale asteroid mining.
And found nothing.
We have found absolutely zero evidence of large-scale technological activities. Uniform silence across all frequency bands. If the universe were a complex ecosystem of hiding predators, there would be mistakes. There would be anomalous flashes of conflict, errant communication lasers, or the shattered remnants of destroyed civilizations.
You'd expect to see the debris.
Exactly. The simplest explanation, supported by the hard empirical data, is that the cosmic graveyard is empty because nothing was ever born there to die.
Or the artifacts of those conflicts are out there right now, and we simply lack the conceptual framework to recognize them.
You mean we're looking at them but not seeing them?
Yes. We look at the universe and see natural phenomena, quasars, fast radio bursts, peculiar light fluctuations around stars. We naturally classify these as abiotic processes because of our scientific rigor.
Right.
But as the Zoo hypothesis or the Transcension hypothesis suggests, an advanced civilization might turn inward,
They might focus on computational efficiency and virtual reality rather than clunky physical expansion across the stars, or they might exist on timescales completely incompatible with human observation.
But that renders the Fermi paradox entirely unfalsifiable.
It acknowledges the limits of our perception. The lack of recognized technosignatures is not definitive proof of absence. It only proves the absence of human-like civilizations operating human-like technology at a human scale.
If we say, they are there, but they use magic physics we can't detect, or they live inside computers, or they exist in a different temporal dimension, we have left the realm of empirical science and entered metaphysics.
Fair enough.
When we stick to what we can observe, measure, and verify, the data heavily favors the rare Earth hypothesis. We have survived an incredible, statistically absurd gauntlet. We navigated the sheer improbability of abiogenesis, the freak accident of endosymbiosis, the stabilization of our planetary climate, and the leap to complex intelligence.
It's an impressive resume.
It is. The cold, hard math of probability points to an empty universe. The silence of the cosmos is not a threat. It is a testament to our profound rarity. We are a solitary spark in a vast, dark void.
I respect the math, but I cannot shake the weight of that silence. The "where is everybody" question remains deeply unsettling precisely because the mechanism of the Great Filter makes so much sense as a future barrier.
The existential risks.
Right. We look at our own society, our struggles with nuclear proliferation, our inability to cohesively manage planetary energy overshoot, the rapid and unchecked development of artificial intelligence.
We see the mechanisms forming.
Exactly. We see the exact mechanisms that could form the Great Filter. Whether it is a technological trap we are blindly walking into because of the Jevons paradox, or a dark forest where revealing ourselves invites swift destruction, the silence is a heavy, ominous warning. It tells us that survival is not the default outcome for intelligent life.
This is the gravity of the Fermi paradox, and why exploring both the early and late filter is so essential.
We have to understand what we're up against.
As we continue to refine our telescopes and expand our search for technosignatures, we are ultimately searching for our own reflection. Every empty star system we scan is a piece of data.
A clue.
Eventually, our ongoing search will prove whether we are an astronomical fluke, a miraculous survivor of the deep evolutionary past, or if we are just the next naive species walking blindly through a cosmic graveyard.
The answer will define the ultimate meaning of human existence. If we are alone, the immense responsibility to survive and carry the torch of consciousness rests entirely on our shoulders. If we are not, then we must prepare to navigate a universe that has systematically silenced countless others.
Is being alone a blessing or a curse?